Hello and welcome to Unit 3. This is going to be the Earth as a planet in space. And this is a picture of the Earth taken from Apollo 8. And that was the first manned mission that actually circled around the moon and actually got to see the Earth rise. And that's what the name of this thing is actually called, this Earthrise. And it was taken on Christmas Eve 1968. If you actually Google this, I'm not going to play it because I do not want to run into another copyright infringement, but this is a YouTube video of the Apollo 8's crew actually reading from the book of Genesis, the start of everything, whether they believe it or not. Okay, so why am I showing a picture of Saturn when we're actually talking about the Earth as a planet? Because if you look here, you actually see Saturn. Saturn is now eclipsing the Sun. The Sun is in the background, so it illuminates the rings of Saturn, some of the gaseous areas. And you can see that there are some other celestial bodies in there. Well, if I do another click, you actually notice that Mars is up there. Venus is right there. And this little body down here is actually the Earth and the Moon. So there's the Earth and the Moon. This is a little more recent picture of Earth, high definition. You can actually see, let me go back to this one. You can see that the sun is actually illuminating this side of the moon because it's illuminating this side of the Earth. Very little shadowing, nice craters. We'll talk more about the moon later on. And in this picture, we're looking at a full Earth. So we're actually looking at the limb, which is basically like this part of the moon. And you can see that the sides facing us are illuminated. Sides facing away are not. But it's actually showing you a very non-flat moon, or at least it looks like it's non-flat. But in relation to the same areas here on Earth, it's relatively non-mountainous, hillless, if hillless is the word. And this is taken by NASA's Lunar Reconnaissance Orbiter. It actually just kind of orbits the moon, and it was a nice high-definition picture of the Earth during the rise from that December 24th, 1968 picture. No place like home. What makes Earth unique? What characteristics does the Earth share with other planets in the solar system? Earth is the third rock from the Sun, because we actually have 4 terrestrial type planets after Mars, and then we start the Jovian planets, and we'll talk much more about those later on too. Earth is the 5th largest of the planets, behind Jupiter, Saturn, Uranus, Neptune, and there's the Earth, and you can see the terrestrial planets are a lot smaller than the Jovian, or the gaseous planets. Earth has one natural satellite called the Moon. We actually call all the other satellites going around moons. We capitalize that moon for us because we are special. There's no place like home. And the Earth orbits the Sun every 365 and a quarter days. And we talked about leap year. Every 4 years we add a day to our calendar because of that. As the world turns, Earth is 70% water. Earth is the only planet that has all 3 phases of the water, a solid, a liquid, and a gas. When you actually see steam, that is not gas, that is a liquid, unless the temperature out here is really cold. That's liquid particles of water. The vapor actually is invisible. And the Earth has a very, we think, because of its density, a very large, about the size of Mars, nickel iron core, which is actually superheated because of the condensation of the planet and the pressure pushed in, as well as radioactive decay. And that gives us rise to our heliosphere, which is actually protects us from gamma rays, other high energy waves, which we'll talk about later, and also allows us to use compass, which the moon cannot use. And that heat actually causes tectonic activity on this 23.5 degree tilted Earth, rotating in the correct direction. Actually, it looks like it's a full Earth, so the sun must be on our side, so the other side is going to be in darkness. And as we rotate into it, we get to night, and then we come this direction, and we'll get the sun in the middle, like right there, and that's when it crossed our meridian, which we do a little bit of review of Unit 2. Pictures of the Earth. You know, for a long time in history, we didn't know the shape of the Earth. Many people actually thought it was flat. Those were not usually the learned people. The learned people actually looked at characteristics around them, like ships coming up over shore, shape of the Earth on a lunar eclipse, and as well as some other things, and actually knew the world probably was not flat, but we didn't know it was so round. And that didn't happen until we actually got up in a balloon, or actually had a camera up in space, and we could actually take a look at that uh, arced Earth. This is Felix Baumgartner. He actually uh, went up 24.2 miles in a or in a balloon. It was actually a helium balloon, and jumped. So you can actually take a look at the Earth, and you can see from 24 miles up, you can see that the Earth is curved. Tectonic plates. The Earth, outside of the Earth, actually has many large tectonic plates and smaller tectonic plates, each moving at about 5 centimeters a year, and this is about what fingernails grow. So it is growing. Some oceans are getting larger, some oceans are getting smaller. The Earth stays the same, and the inside of the Earth is actually cooling off every time we give off this heat. The inside of the Earth cools off. Due to the Earth's rotation and tilted axis, the Northern Hemisphere receives sunlight in larger amounts some parts of the year. Talked about that when we talked about summer solstice. Lesser when we get winter solstice, and then the entire planet actually receives the same solar radiation as it normally would during the two equinox. So in the northern hemisphere, the summers are warm, and in the same summer solstice in the southern hemisphere, the temperatures are colder. Also, the wind patterns are different for each of the hemispheres, and this is due to something called the Coriolis Effect, which we may or may not get to see. And I'm not sure what the USA Today Com Weather Resources is, and I can't click it because it's not a clickable link. I must have put that on there a long time ago. But winds move in a counterclockwise direction in the northern hemisphere, and they move in a clockwise direction. And if you take a look, you can see these winds moving in a counterclockwise direction down here, in a clockwise direction down here, and it all is due to what's called the Coriolis effect. This is the intertropical convergence zone. This is where wind actually converges and goes up, and this gives rise to clouds and precipitation, which is why we have the rainforest here. And then we have to have divergent areas too, which are located here, and this is why we actually have the desert areas in this location, all driven by wind patterns. And Earth null set, which I will show you as soon as I figure out where it went. Maybe I closed it. Let me click it again here and drag it over for you. This is the present view, and this is the remnants of Hurricane Nicole. I don't know if it's still a hurricane. It actually still, let's take a look at some wind speeds, 129 kilometers. Still is a hurricane. You can see it's up in the North Atlantic. It actually went through Bermuda, which is right here late last week. And you can see that beautiful counterclockwise flow. And you can see the clockwise flows down here. And this is a map that you can spin around and watch. And you can see typhoons over here for the Philippines. You can see another one. Actually, looks, I can't tell. That looks like that's maybe tropical storm. Probably has a name, but I'm not aware of it. You go down and look at the South Pole and actually see the winds going around it. And you can go up to the North Pole and see the winds going around it. As well as if you find you want to go into your area, you can zoom in. And actually, that's as far as I can zoom in. And you can see we don't have a lot of wind. The wind is coming out of the south. So we may actually get warmer temperatures than if the air is coming the opposite direction. And looks like the air is actually moving around to make Nicole. And you can see the stronger the wind that comes in, of course, the stronger the force. And that's beautiful. And this is not showing you in real time. It's just showing you that the wind's moving 58 kilometers. And I think you can actually go in here and change that to I'm not seeing it right now. But I think you can actually change these to meters per second, miles per hour. So yeah, 84, that's still a hurricane. That is a sustained wind of larger than 74 degrees. There's 74 miles an hour, so that still is a hurricane. That's Hurricane Nicole. And if you look at the eye, 1 mile per hour, very calm winds. Another thing you can do with this, and these are all generated by satellites, is you can change the look. Very weird looking manipulation of the Earth, and some of the really wild ones. This is supposed to be a very good representation. It's almost like you took that spherical Earth and cut it up, but they're trying to retain its same size, so that's much better than the map that's behind my desk. And then you can take a look at this one. This is probably the most realistic, maybe common type map. It actually shows the North Pole as being smaller than the equator, but still much larger than it is. And again, there's Hurricane Nicole. Okay, and that is our stop. Okay, thanks. That is 3A. Bye.